get started. So welcome back, everyone. Today we're gonna start the next chapter, which is computer vision using CNN with PyTorch. So now, okay, my BS code, you can see everything is clear, right?
Yes.
Yes.
Okay. So there are some references for the book, you know them already, and for the I always push our notebook here that I modified in my GitHub repository. You can also check them there. So what's computer vision? So we all know computer vision, is part of machine learning that allow one to deal with images, understand the image and, work with them. So that's the computer vision. We all know that. But there are different kind of tasks for the computer vision. So for example, image classification. As we have seen previously, we can do text classification. For example, you can classify to tweet into head and non-headable. That's called text classification. But we can also do image classification, which can be either binary or multi-class. In our previous session, we saw how we can use binary and multi-class classification. So computer vision involves image classification, but we also have image segmentation, image detection, object detection, image generation. All these ones are computer vision. So what's image generation? Now we have many AI models such as DALL-E that does image generation. That's called image generation. And this is called object detection. And this is called image segmentation. Given a single image, you segment the image into multiple stuff, right? So all these ones are, computer vision problem, and one can be able to use them to solve such kind of problem that relates with image. Now, what we're going to cover in these sessions, we're going to build a classification model for image using PyTorch, and there are a lot of specific stuffs that relates to only computer vision. So for example, we will see what is touch vision transform, touch util, all this stuff. This is the same structure you remember we saw in previous session. They're still the same. We just, previously we just work on some numbers. Now what we are working on an image, because when you are working on image or text or video or everything, they have different way to represent the data, and so there are some kind of things that differ from one domain to another. Right. So for computer vision, we're going to see a lot of stuff. Number one, we're going to see what are vision libraries in PyTorch. So what do I mean by vision library in PyTorch? If you are working on NLP, the libraries you'll be working on, they are completely different from the libraries if you are working on computer vision. So there is some kind of modularity. PyTorch comes with different libraries for each kind of niche. We'll see how we can load data. We'll see how we can prepare data. We can also see how we, build a baseline model. So we will start by building a baseline model that use linear model. Then we can scale and go and build a model that use CNN, neural network. And finally, we will see how we can, save our model. Now, in computer visions, what are some of the libraries in computer vision, in PyTorch? So let's see something like this. Can you see my screen, my browser?
No.
Okay, let that be. Okay, this one?
No, it's not a browser. Yes. All right, it's close.
Okay. Okay, what about now? Can you see my browser? Can you see my browser?
Yes.
Right. Okay. So if we look at this, we can see, for example, this is PyTorch. So if you see, like, you can see touch audio, touch text, touch vision. Can you see that? So touch text, if you are working on NLP text, so most of the libraries that work so text are here. But if you are working with vision, something like that, most of the libraries are under touch vision. So you can see it touch vision. So you can see, like, under touch vision, there are a lot of sub libraries, so packages, many other things. For example, if you want to transform your image, if you want to retrain models, there are a lot of stuff. build data set, some function operators. So you can see there are a lot of things. So this tells us that if we are working on a particular domain, there are a set of libraries or packages that we work on. So we can see here we have touch vision, touch data set, touch models, transform. So this touch vision is just content data set, model architecture and image used to transform, for computer vision problem. So we can see touch vision because this is a base package, package. Then we have data set here, contain the data set, model, contain model, transform, contain many functions that you can transform your image. And, here, these data loaders can be used to prepare your data, but these are not only for image, but we use data loaders and data set also for other like text NLP stuff. So these are some of the things we will see. Let's load them. So here we can see we have these, and now here we can see we have we import vision. We import data set from touch vision because we say this is the vision in the base. So we say from touch vision import data set. From touch vision, the transform import to tensor. So this function allows us to transform anything to tensor. Matplotlib, we know this, and yes. Okay, so we load everything. Now let's move on. So before we start, we know we need to decide what kind of data set we are going to use. So for this session, we're going to use a data set called Passion MNIST, which is basically somehow version of original MNIST dataset. So this is another dataset called MNIST dataset. Let's look at what is MNIST dataset. MNIST dataset. So you can see this is MNIST dataset that which is a dataset that literally start breaking the deep learning space due to the experiment on this dataset, and there are a lot of stuff regarding to that. This is MNIST dataset, but the dataset we are going to use is called Passion MNIST, which is basically a variant of original MNIST dataset, but this dataset is not. You can see MNIST dataset is somehow colored, but this one, Passion MNIST, grayscale image data set. So the two things, when you hear MNIST data set is different. When you hear Passion MNIST data set is different. So we're gonna see this is Passion MNIST. So how can we get the data set? So we already saw that these things, touch the vision, the data set, it allow us to load data set. So this is what we're gonna use. A lot of things that you're going to use with the data set. So here we can see, I said trend data, I said data set that Passion MNIST, because inside the data set, there is a data set called Passion MNIST. So let's go to PyTorch and see this. So if we go to data set here, so you can see here, we have data sets. We have different kind of data set. You can see the Caltech, CPAR. Let's see Passion. So you can see Passion MNIST. Can you see Passion MNIST? All right. So you just need to call this Passion MNIST. And so we can see Passion MNIST. You can see there are a lot of argument. What we have argument road, we have train. Train if true. It return the training data, download if true, it download, transform if true, a function to transform the data that take PIL image and return transform versions, targets, and it returns image and target. So we can see this function. When we have the called the MNIST data set, what it will return is the image and the target. So you can see when we say the image, we mean the features and the target. So it returns this kind of stuff, which is the return type is tuple, which is the image and target. So that's why here we have the return type is tuple. So you can see here, I said dataset Passion MNIST. What it will return here is the image and the target, as I show here, the image and the target. And you can see here we have many argument root where it will save the data. So it will create a data folder called data. Through train data, yes, to download train data, because here I say train data, download, yes, transform, yes, transform this because the data, it was in an image, Python image, PIL image. So to tensor will transform the data into tensor that we obviously use. Target transform, don't transform the target, right? So, so here we can see we download them, and here we say test data. So here the only difference here is when we say trend, we say false. So when we say trend is false, it means we mean test data. So when we run this guy will now already download now the training set and test set. So here I made mention what is PIL, Python library that prefer image. So all our image were in PIL format. So here when we are downloading them, we ask the PyTorch to transform them into tensor. Okay, so let's look at our trend data. So here we have our trend data, this guy, we can see trend data. You can see that's a number of data point. We have 60,000 location, which is split is this trend, transform to tensor. We can see many information here as well. So remember when I called trend data, I said the first one gave me what it returns. Remember, I made mention the it returned truth in the image and target. So partial amnesty that. So when I say trend data, you can see I assigned 2 tuples here because it returned a tuple, 2 things. So here you can see I said trend, give me the first image, and it is level. So here you can see image and level. Level means target, right? So here it means it's giving me target, which is level. So when I run this guy, so it will return the image for this image. So you can see the tensor for that image. So it means we converted one image. Remember this data points, all these data points represent image, one single image. So what is the target? The target is 9. So all these numbers, they mean one image. We'll talk about this. So they mean, and the target level is this number 9. So if we look at what is the shape, so you can see like the shape of the image is 28 by 28, and there is something 1 here. So remember this, as I said, computer visions, they have different way to represent the data. So if you are using video, if you are using text, everything, they have different way to represent the data, right? So that's why here we can see this is the shape of our image. Now, any question before we move on? Any question? Okay, so if there's no question, so what this means? So it means in computer vision, we represent our data with some format, which is called channels, height, and weight. So let's look at this. This is the input of our data. This is one image. So this is the height, this is the width, right? So we convert this image into tensor. We already know anything we want to do deep learning, we convert them to tensor, right? So here we convert it to tensor. Now, since we convert this guy to tensor, now, how is the image represented in PyTorch? So we have different ways to represent image in PyTorch. So we can see here we have batch size, here we have width, here we have height, here we have color channel. So what does this mean? So remember, one thing we should know is that when we are training a model in deep learning, we don't train, if I have 1,000 image, we don't train the whole 1,000 image at once. We divide those images into batches. So that's now, this is called batch. This is width, the width of your image. This is height, the height of your image. This is color channel. So we have what is called color channel, which we'll see in a bit. So in a nutshell, what I'm trying to say is that image in PyTorch is represented in this format: batch, width, height, and color. So that's why here we can see, if you see none, it means there is no batches. You are trained, it is all the images you want to train, no batches. Now here is 2, 2 means you have width and height, and now here is 3. So this 3, it means, who can tell us what this 3 means? Anybody had the idea what this 3 means?
It is the channel, I think.
Yeah, color channel. So the color channel means this is a colored image. So if your image is colored, then you put 3. If your image is grayscale, that is black and white, then you put 1. Because the grayscale, we have RGB, that is, yes. So that's why here we have the channel. Color channel is 9, but it's no batch. But if you have batches, like for example, you have the batch of this of your data set 32, which is somehow default batches we use in computer vision 32. So we have this. So if we have an input data, what we do, we change it to tensor, which are able and pass it to machine learning algorithm. And now this, your data point must be represented in this format. So you see, this is different from what we saw. And now you output something here. Now let's look at what is batch size. So what is batch size? So remember here, let me come back to this figure because I like it. So if we want to train a model in deep learning, what we say, we take our model, our data, we pass it through some layers to make a prediction, and now compare with true target, right? So here, previously, we took all the data and make the prediction and compare the loss, and now go and go to another round, right? So what is a complete round here to make a prediction and come back here? Who can tell us what is that complete round name called?
It's the Epoch.
Epoch, yes, it's called Epoch. But now, because you work on the complete data set, but now, since we say we are dividing the data into batches, so let's look at what will happen. Now, if I have now 10 points here, the data set is 10. I don't want to train all the data set at one point. I want to create batches. So maybe the batches of 2, 2. Now, if I could collect one batch of 2, now I put it here. I create a prediction. I compare the loss. When I compare the loss, because I'm doing batches, I'm not going back to update. If I go back to take the next batch, I do not complete an epoch. Remember what is epoch? Epoch is a forward and backward for complete data set. Now, if I have 10 image and I now take 2, assume I'm doing batch. I have 10 image, I take 2, and now make a prediction, and now compare the target, find the loss, and now go back and take the next 2, make a prediction, come back, take the next 2, make a prediction until so it is when I completed, because I have 10 images and now converted them, I divided it into batches. I have 5 batches. Then it is when I do complete 5 rounds, that is, I make 1 epoch. Remember, an epoch is complete forward and backward for the complete data set you have. That is 1 epoch. So this means that when I do 1 epoch for the 2 data set and now find the loss function, and I found that the loss function is very large, I will update the weight. So this means that using an epoch allow you to update weight quite often. So if I divide the data set into 5 batches, now I update my weight 5 times. But if I'm doing only a single epoch, that is, I pass the whole 10 images here, I update my weight. How many times I update my weight if I pass the whole 10 image? How many times?
You didn't.
Times.
Eh?
Once. 5
It should
times.
be 10.
Okay, let me come back. So
Yeah.
if I'm using batch of data set, so here I have 10 image. Now, if you are using batch, you will not train the whole, you will not pass them. You take the first batch, which is 2, and now train the model, find the loss function, compare the target, and I have some kind of, a lot of loss. So if we have a loss, we remember we use optimizer to update the weight, right? So I would update the weight. When I update the weight, I have my model updated, and the optimizer tells my model, oh, you did a very bad. This is how you update. This is the way you can make a good prediction later. Now, here I have updated model, but I will take my second batch, which is the second one. Now make a prediction with updated layers. I will do this up to 5 times because since I have 5 batches, I will do it 5 times. That is 1 complete epoch. But when you have your 10 images and you want to do a single pass, so you see in the when I have 5 batches, how many times do I update my weights?
Just once.
Once.
Yes. If I'm using the whole 10 images.
The whole, yes, one.
So so I want to make some point here. So you can see this is the difference. What is the difference between epoch and batch size and epoch? We now understand what is batch size and epoch. You can see a batch is a subset of the training data. The batch size is the number of training example in one batch. An epoch is 1 forward pass and 1 backward pass of all the training example. You can see. So when I'm doing batches, even though I take 2 out of 10, When I make forward pass, I come back, update the weight. I do not complete an Epoch because it's not complete training data set. So yeah, so this is an example. Some people may be confused. What is an Epoch? What is batch size? And we'll see in the next what is the advantage of using batch size. And here you can see in the first, for example, let's say you have 1,000 training examples. If your batch is 500, then it will take 2 iterations to complete 1 epoch. Can you see that? Because
Yes.
yeah, but in the first iteration, you take the first 500 example from 1 to this and do the forward pass and backward part. In the second iteration, you take the next 500 and do. So I think now we understand what is the difference between epoch and batch size. Is that correct?
Yes.
Okay, so going forward,
Yes.
we have what you call image size as well. Now, there is issue with how we can represent our image in PyTorch. So as I said, we can represent an image in this format. You can see this is channel, this is the height, this is the width. This is what we call channel first. There is an issue, some deep learning architectures represent. So here you can see, for example, I have 3, 28, and 28. So some deep learning framework represent an image like this with channel first and then image. But some other deep learning model represent a model as like this, 28, 28, then we have 3. This is called channel first. This is called channel last. They are all valid. PyTorch and TensorFlow do channel first. Keras do channel last. So you should know if you are using any stuff, what is happening. And this number 28 and 28, it just gives us, how our resolution of image. If you have large number, it means your image is very large, it's very, so it's very big. You can see you can have these up to this number. Or when you have large resolution, it means your image, it will take more time. If, for example, I'm using 1024 image, 1024, it means my model will take long time to process this stuff. So this is basically, what is the meaning of this data. Now, what is this? So here I told you, if you are using colored, this channel, if you are using this, if you are using grayscale, this will be 1. So what is grayscale? So a grayscale is images that are black and white. So let me show us a grayscale. So a grayscale, 1 is white, 0 is black in grayscale image. Now 0.5 is gray. So anything in between 0.25, dark gray, 0. This is what we call grayscale image. Now you can see we have one channel because which is grayscale, then that's why we have 1. So if you see any channel 1, so it means the image is grayscale, black and white. But if it is 3, it's black and white. Black is colored. So that's the meaning of grayscale. And in computer vision, colored image, sometimes I use, as you can see here, because it allows us to capture a lot of stuff. Okay, cool. Okay, let me this guy. Okay. No, the magic. Okay, leave it. I just write something, a script, just so that when I run this guy, it will not show me an error. So I don't know what is happening. Yeah, let's go on. So the order of dimension. So you can see the order of dimension of our image. Here we have 1, here we have 28. So here what I talk about is, sometimes you see what we call this order, is called color channel height and width. You see CHW, but you can also see what is called CHW, or this, which is kind of channel last, channel first. But if we have, our image does have what we call batches, because here we can see there is no batches, then you see it in this ways, in this format. N is number of channel. Can we see it? Not number of channel, batch. So we can see N, C, channel, height, and width. So in the future, we'll be seeing an image like this. Okay, this is the image I showed. This one, you can see it. This 3 means the batch. You have batch 32, and you have the image height, image width, and this is, colored image. That is, so this is how the shape of your image will be in PyTorch. In PyTorch, I said it's color channel first. So it will be channel at the beginning in PyTorch. Okay, so let's look at our data set size. So this is our data set that we downloaded. We have 60,000 data set. Let's look at test data set. We have 10,000 data set. So we have training data set is 60,000, test data set is 10,000, right? And now let's look at the class names of the data. So we can see this is a class name. So we have the data set, we have different images, trousers, this is the class names, right? The thing is here, you can see what I did is train data, the data, and train data, the target. So if you download in PyTorch, we download our training data. How can you access your data? Then you run the data. If you want to access the target, you run the target. You remember, this is how we download the data set. Yeah, this is how we download the data, right? Dataset.python and it will then train data. So if we want to access the data and the target, that's why I was saying we need to run this, train the data and train the target, give you the target. And this is for the test data. And now what about the class names? So we want to see the class name of the data. So we have the classes and it gives us this one. But you remember when we want to train a model, we will not train the model with this, full over direct sneakers. We train a model with numbers. So we want to see the IDs of each class. So when you call this one, t-shirt 0, trousers is 1, full over is 2, dress is 3, coat is 4, standard. So you see, so this is just looking at set. Right. So okay. Any question before we move on? Any question? Let's move on and visualize our data set. Any question? Okay.
Well, sir.
Yes, go on.
At the image.
Sorry?
On the image.
On the image.
Go on.
On the image, we have a gray.
Yes.
You get me? So what if the color is at a secondary color, because RBG is sign 1, 2, 3. So what if the image is at a secondary color or tertiary color? Do you get me? Yeah. So yeah. So what we're trying to say now here is 2 things. If you want to work on grayscale the images, you just put 1, the channel. If you want to work on colored image, then you put 3. So your question is saying what? PG are the primary color. Do you get me?
Yes.
What if the image is for the secondary color or tertiary color?
Variation she RGB.
Yes, exactly. Yes, exactly. So what you are saying here is, the RGB exactly. So we have
whatever it is, most of the colors are produced from these 3.
So the RGB, we have this. Now, if you want to produce any color that it will start from this 3 color, their intensity. So let me see. Give me.
Yes, from my knowledge of fine art, most of the colors are produced by combining these 3.
Exactly. Give me an example of RGB color. No. What am I working on? Let me show you some example. No, you are nonsense. Anyway, so the point I want to make is that if we have RGB, right? If we have RGB, then if I have, for example, 1 color from
this, it will be some kind of intensity, G be some kind of this, and this another kind of, continuous value. So combination of them, that will give you any color you want, RGB. Any color you want to have, you can generate them from RGB, any color you want. So yeah, so something like this. So let me,
that is why gray was separated. Gray and ash color belongs to black, but all others.
so you see this. So you see this. So all these RGB, any color you want, you can represent them. Just change this here. Then, so all we need is just to supply the this data point. It give us any color we want. Right. So, okay, let's move on. So, okay, we want to see we want to visualize our image. So we already know that our image is gray image and is 28 by 28. That is why we have one. So if you want to do visualization, we must take out one, we must squeeze one so that our image is 28 by 28 only. So let me show us what I mean. So here you see, if I squeeze the image, we already know what is squeeze. It will remove one dimension, right? So we can, no, it's not defined. Image, squeeze. Oh, okay.
Image.
Yes, you can see we have 28 by 28. So what I'm trying to do, we want to just preview the picture of one image, but because the image we have from PyTorch is we does have color channel, which is one, and this at the side. So we want to remove this one so that we can float the image and see. So how can you remove any singleton in PyTorch? We already saw in our previous session, we need to call squeeze. It will remove that, right? So here now, that one I want to show. So when we run this guy, we can see here image the squeeze. We call a squeeze on the image, and now we say gray map, and now we can see this is one image. And here we also, try to see different images. So you can see here I create a figure 9 by 9. So you can see this is 9 by 9. And I create a row of 4 and column, 4 rows. Column 1, 2, 3, 4, 1, 2, 3, 4. I mean, this is just matplotlib. And now here I create a random index of the data. So here I create a random index, create a random number, right? From 0 to the length of the training data, and item, call an item to change it to a number. Because it is in tensor when I create a tensor, but calling an item will return that tensor into a single number. So here you can see I index the data, trend data, using the index I generated. And now for any index here, because I'm doing for loop, it will return the level and the image. You can see that. And now for that, I plot the return image and level. And in each subrow, in each row and column, we have, the image and row. So here, that's what we have. You can see this. These are some of the image in the data set. Right. So now what we want to do is we want to train PyTorch classifier to be able to classify image, if it is sneaker, if it is shade, if it is sandal, if it is ankle, whatsoever. Now, before we do that, we must understand, preparing how you prepare your data. Because remember, we said this data we want to put in batches, right? We don't want to just train the data set, everything. It means we need to find a means that we will create some batches of our data set. So that's what we call data loaders in PyTorch. So PyTorch comes with one thing called data loader. So what is data loader? So remember here, when we started, we said data set. So we finished with data set. So data set allow you to download data set from PyTorch. And now here, what we're going to see is data loader. Create a Python iterable data set. So this will create iterable, create batch for your data. If you want to create batch, so you will need to use data loader. So let's move on and see how we can have our data loader. Okay. All right. Any question before we move on? Any question? So we want to use our data loader, right? As I made mention. So yeah, so this is, let me go to the code directly. Remember, we have our data set called that we already downloaded called trend data, right? Now we want to create data loaders. So data loader allow you to create your data in batches. So here we import this from this import data loader. We could specify the batches we want. We want 32 to be the batches. Now, all you need is just to pull this data loader. Data loader, specify the data set. You remember we have our training data, so we provide this. How many batches you wanted? We say 32. Do you want to shuffle the data? We say true. That's it, simple. This will automatically create batches for your data set. Now, also, since we create batches for training data, then we need to create batches for test data. So here we provide this. We said yes, and we say shuffle. You know, we say don't shuffle because we shuffle here because we want our model-wide training to learn from shuffle data sets. We remember the importance of shuffling the data, but you know, for test data, you need not to shuffle because you want your model just to predict. So there's no need to shuffle the data. So when we run this guy, now it already create, you know, the our batches. And when we run this guy, we can see length of the train data loader is 187 batches of 32. So remember we have 60,000 of training data. Now we create batches of 32 of 30. So 32 times 1875 will give you 60,000. Also this one, our data set test data, we have 10,000. So this 313 by this will give you the equivalent number. This is how we can create data loader. Simple as that. You just call this data loader. And now when we want to see this data loader, we can go to PyTorch here and see data loader, PyTorch. Yes. So, you know, yeah, data loader, right? So we can see this is data loader, right? There are a lot of stuff. You can see data set, you have which data, training data or test data. What is the batch size? What is the shuffle? And the batch size you can see is optional. So when you don't provide it, you mean you want to use the whole batch. If you want to shuffle, if you want to sample, there are a lot of stuff that we may not discuss, but in future we'll discuss them. Now we are working on very simple stuff. Now, why do we train data in batches in neural network? So there are many issues. Number one, memory efficiency. Now, if you have 1 billion data set or 1 million, you may not fit it into memory in a single memory. So you create a batch. So you batch, that will create efficiency. Parallelization, you remember when we are training deep learning, we train them on, you know, GPUs. So you'll be able to train several batches to different GPU in parallel. So this one advantage. And stochastic gradient descent. This is what I explained, that because we changes the weight, we update the weight at each batch, then our model will learn better than training the whole data set and update the single weight. This gives us an idea what is called stochastic gradient descent. Training on batches of data allow you to perform stochastic gradient descent. That is using gradient descent on the subset of the data, which is popular optimization method. SDD involves updating the model parameters. We can say SDD update the model using small batches of data at a time rather than the entire data set. This can help the model to convert faster and avoid overfitting. I think this point made it clear why I was trying to explain why we need to create the batches of the data set. Does it make sense? Okay, so now we understand now how we can create a data loader. Let's move on. Any question before we move on? Okay, so before we move on, let me recap something that we'll be able to see, which is called an iterator in PyTorch. So I mean in Python, because data loader is an iterator. So let me create some lists. This is a list, right? And now I create something iter here. Remember, this is a Python. Calling this iter, change my list to what is called iterator. Now I run this guy, and now I change my list to iterator. So now how can I access each element here? How can I access 1? How can I access 2? How can I access 3? How can I access 4 or 5? Now, remember, if I'm using my list here, I can just have this. When I have this, it can give me the first one, right? When I have 1, it can give me the second one, right? But what about if I want to, use like, iterative function in some kind of ways? Now, if I call this guy next on my iterator, it give me 1. Can you see it give me the first one? When I call the next, it will give me the second one. When I call these guys, they will give me all, the sets, But when it finish, you call iterator, it gives you an error that, it's finished. This is what we call iterator in Python. Now we'll be able to see this one in a section. So I just recap it so that we remember what is an iterator in Python. Any question before we move on? Now, so the idea here is because we create different batches here of our data, we create batches. Batch 1, how many batches do we have? We have for training data, we have 1,875 batches. For test data, we have 313 batches. Now, how can I iterate, take the first batch, go to the second batch and train? Because remember here, I said we'll be taking a single batch, train it, go back to take the next batch, go back, take the next batch, go back. Now, how can I make Python to take one batch, train it, go back, train it? That is how I will make my train data loader iterator. So I call iterator and call next. So here we'll take each batches and assign this one. So this is the essence of why I introduced next and iterator. So if you can see here, I said, what is the length of the first one train feature is 32. Can you see that? That is the first one is 32, the length of the batch. Now, when I run this, the next one, it gave me another batch, so it's still the length. So that's the essence we have next iterator. It allows you to iterate to pick one, next one, next one, next one, until you exhaust the whole batches you have. Okay, now let's do my recap what we have seen. For us, first what we did is to download data. We use this dataset that MNIST. We download data and test data, which is this. And now we went and create a data loader, which is this. Using data loader and this test data, test data. But after creating the data loader to create batches, how can we make our model? If we come to train it, to iterate, to select, then we call this one. So here we create everything. Now the next thing is train our model in that way. So this is just image trying to use full image to see different. You can see here the iter here I already have here. It's when I run this guy, it's giving me different images. Yep.
So, Doctor, why do we train only? Why do we shuffle only train set?
Good question. So if you are training data, because so here, okay, here do we shuffle the training data? Yes. Do we shuffle the test data? No. Why? Because we want to see the models perform on the same data each item we test it. We want to see how consistent the model is. So for example, now I train a model. Then when I train the model, I give the model a data set of 1,000. The first 500 is all trousers in the test set. The last 500 are all sneakers. Now, when you want to make prediction, you want the model to predict all the 500 to be the trousers, right? You don't care whether they are shuffled or not. You are even, you understand what I mean?
Yeah, I am also.
Because you are training the model, you are evaluating the model on test data. So you don't care about whether it is shuffled or not. So you don't need to shuffle the model. Yeah.
Okay, I guess I can say a sampling bias in such a way that I train my model. The reason why I asked you this question,
Yes.
but for me, since I'm still learning, I shuffle the entire data set. Then I split the data into training,
Yeah,
train,
I understand.
and test.
Yeah.
So But along the way, since I'm dealing with the regression problem, along the way, I realized that two of my models that I have tried to run, the test set is less than the training set, which means, you understand?
The test set error.
Yeah, the test set error is less than the training error.
Oh, the model is doing what then? Is not
Because
doing,
like there
it's not
is
doing
like sampling bias.
yeah. The model is not,
Sampling bias, because I shuffle the entire data set. That is why I was asking
yeah.
this question.
So here, as you can see, we'll come back to this, but you can see here, also, if you remember in our previous sessions, while we are doing the machine learning, we shuffle our trained data and test data, but you can see here, they are suggesting, you know, you don't need
You
to
can only
shuffle.
shuffle that
Yeah, so we can come back and
trained data.
yeah.
Okay.
So let's go to model building then now. Okay. Okay, model building. So we want to build model to do a baseline, to perform a baseline stuff. And then later on, we build very sophisticated models using CNN. So when you are trying to do machine learning or deep learning, the first thing you need to do is to create a baseline. What do you mean a baseline? A very simple model. And now when you create a very simple model, you see the performance, then you say, okay, this is my baseline. Now your aim is to build a model very that is better than baseline. Yeah, so that's what we do in machine learning. Just build a baseline first, see the performance. Now build a model that outperforms the baseline. So here we use you know, linear layers to build a model that will do image classification. But later on, we'll come back and say, okay, linear layers will not be the best way to do image classification. CNN, which is architecture image classifications. But today now, this first step, we try to do a simple user linear class. So you see, when you have an image, the first thing you need to do before you do is to flatten the image tensor into to be a single, to be a single what do we vector? Yeah, vector, and you pass it. So that's what we call flattening. So here we'll see a code here. If you want to flatten in PyTorch, we have what is called nn.flatten. So you can see here, I create a model called nn.flatten model. Then if I have my data here, I create a data, a single data point. Now I pass the single data point to flatten layer. Can you see that? Now, when I run this guy, we can see here, if, for example, already I have 1 by 28 by 28 image, when I flatten the image, now I have 7H2, that is this by this, it gives you this. So you flatten, if you have an image, you flatten it and pass it to the convolutional other layers to do, because our linear layer, sequential layer requires flatten image. That is why here we're going to use flatten. So if you want to use linear and your data set is not flattened, you need to flatten it so that you can pass it to the linear layer. So that's why here we create a flatten you know, stuff. So you can see here we want to create a model class and put nn partition class empty version 0. We subclass the nn module. What is the input shape? Integer. What is the hidden unit? Integer. Output shape? Integer. So this is called who can tell us what is a called? What is it called? We have int. What is it called in Python? What is it called? We call this I think we call it edit annotation or something like that. So here we can see it's telling us the return of what we are expecting to serve to this function is integer. This is integer. This is integer. So now here we have this super in it. We subclass this, and now here you can see we're using nn sequential. Then nn sequential, you can see we pass nn flatten to flatten the image. And now here we are using input features that we have, output feature hidden in unit, and now nn layer, the next one input feature, the hidden in, then we have this. So if you have not
come here yesterday and last few weeks, you may be confused why we use this, and you can refer back to the previous video uploaded. Yeah. So, and now here, this is the forward pass. So because we are using NN sequential, we can just call self.layer stack, which is this one that I created. We call the object because it's NN sequential. Remember, if we are subclassing in different ways, the other way we see, this is not how to do that. So here we can create the model, and you can see we can instantiate the model. So here we create a model. We can instantiate a model called model 0 using Python and MC. What is the input features? 28 by 20. What is the hidden unit? 10. We want to use 10 hidden. The output shape. So because we want to output predict the classes from how many classes we have. So we can see we have different classes, right? Where do I call class names? Yes, you can see we have classes. I have class names. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 images. So here, remember the output features is the size of your class you want to predict, right? How many images are there, right? So here we can see, that's why here we say the length of class name. So here is mean the length of the class name 10. So we want to output 10 stuff because we have 10 classes. Okay. Any question before we move on? Any question? Okay, so everything here is similar to what we have seen previously. Yeah. And now here we create a model. We push a model 0. And now model 0, we create a dummy data set. And now we can pass that dummy data set into model 0. So we can see it. Now we have, the dummy model give us some weight, which are, random weight, right? And we can look at the the weight, line weight here. Okay, this is all we have seen in previous session. If you are missing something, if you think you are lost, you please go back to some of the videos we did. Yeah. So the next thing we remember, we need to set up training loss optimizers and evaluation metrics, which we already saw. So here we can see here, here they are downloading the some functions, helper functions from their GitHub repository. Remember in the previous session, we have many functions for calculation accuracy and many other things. So here, if we go here, let me take this guy. If we come here, you can see this is functions, many functions. So you can see worksuite directory. We have float decision boundary function. We have float prediction function. We have calculate accuracy function. We have print a lot of function. We can say a float cast. So what he's doing here is that instead for us to rewrite those functions, we can download them and now just call them. So here, this code download those this function, this helper function from GitHub repository here. So this one download them. And now when we download them, you can see it's called helper function. When I open here, we can see it here, I think. Can you see it? Helper function is downloaded now. So you can see it here. Now, since it is in our folder now, we can call it. So from helper functions, it is now somehow a module, right? Because you save it somewhere else, you can call it just like module. So from helper function, import accuracy function. So you can see if we go to this helper function, we have accuracy. Where the accuracy? Yeah, can you see accuracy function? So you can see that what it's doing is calculating the accuracy. We can take this code and put it there, but it's good to just call some function from somewhere else. So you can see, and because it is called helper functions, the name of the file, helper functions, that is why here we say from helper function import this accuracy. And now so here we have loss function is cross entropy. We define our cross entropy loss function, and we define our optimizer. So here we're using the parameter of the model is model 0.params, and the learning rate is this. So this is also, and we have seen this thing already previously. Any questions? So here we can see we set off our accuracy function, we set off our loss function, we set off our optimizer, right? Any question? Okay, so why are we doing all these ones? We are setting up the ingredient we need to train our model, right? Because if we want to train a deep learning model, you must have accuracy, you must have a loss function, you must have optimizers, right? And now we create a function timer. So here we create a simple function that will time the time between the starting of the training and the time of completion. So we call the function called print train time, and we have the start, it take the start, the ending, and device. And the function, we can see it, total time, it start with the end minus start. So print the total time. So it will print the time it takes for the model to train a model. So yeah, so this is just an example of how the function works. All right, so next is create our model, training loop for the model. We now finish gathering all the functions, ingredient that will allow us to train our model. So creating a loop, training loop and train a model on batches of the data, we need a lot of stuff. So one of them here is basically to loop through each epoch, loop through the training batches, loop through the training batches, So we'll go through each one of these and see how it works. Now, before we go that, let me introduce something which I will show, which is called TQDM. So let me show us something here. If I'm running something, I'm doing for loop here. When I'm doing for loop, I have an epoch 100. Now, if I'm going through 100, 100, 100, 100, and now printing some values here, this is the result. But when I want to, for example, see, let me use this. When I want to see the progress of how the loop is going, we use something called TQDM. So let me show us what happens. Now, when I run this, you can see here the something, but here I said, okay, for epoch in, I wrap this range in what we call TQDM. Can you see that? When I click here, can you see it giving me like the percentage that the model is taking? So when you have a model that's taking like 50 minutes, so you see that it is 2%, 3%, 3. So this is some package that allow you to do that. So we'll see this one as well. Also, let me remind us something called enumerate in Python. So here, if I have a list, and now I call enumerate on this, let's look at what enumerate will give us. Who can volunteer to tell us what will enumerate returns?
So when we use enumerate, we usually convert an object to array.
Okay.
In such a way that each element or item has index.
Yeah, exactly. Exactly. So yeah, so here we can see when we have a list, we call enumerate, but when I call the enumerate, it give me enumerate object. So sometimes what we need to do is just to call maybe a list on top of it. So here you can see I call list on the enumerate. So when I call this, it changes. So here you can see the first one is it. So it will put this is the first one 0, it put it in this top, right? And you can see select is the second one. So one is, so this is what enumerate does. So we'll see them, these two things, TQDM and this in our training loop. Okay, let's get started. Get the bells. This is the most important thing, new thing that we have seen. Training a model. Previously, we trained models, this loop, but it is not with batches. Now here, the difference now, we will train a model in form of batches, which is different from what we saw previously. Any question before we move on? Please ask question if you have. Any question?
Yes, I have one.
Okay.
Sir?
Go on, Falalu.
Yes, what I'm saying for the batches, do we have a maximum number
Oh, batch?
for the batch? Assuming that we have maybe 50,000 data point or data set,
Yes.
then for the can we have a maximum number of it?
Well, I don't know, but all I know is the one of the widely used number of batches to train models sometimes is 32. You can see 16. You can see 64. Sometimes the reason why we make a batch, number one, is memory efficient. So when you have like your memory of your computer is not good, it's just like very small, and you specify a very large batch, so the batch will not be fit into your memory, and that's why sometimes people, you can see they are training on Colab. Colab, Google Colab, they said, what is the error is written out of memory or something like that. Yeah, I forget the error. So it means the batch error. Let me. Yeah, we'll see something automatic batch sizes as well that automatically create batch for you, or different between Epoch and batch. We discussed this. Anyway, we'll see a lot. So for now, I think I cannot say like there is maximum batch size, because if you have a very infinite resources, many GPUs, you can use as many batch size as you want. But remember, the smaller batch, the more smaller the batch size is, the more you iterate the data, the more you update the weight, the more accurate you are. So I think there is some kind of trade-off. If you have smaller batch, the accuracy will be better. Yes, if you have, but it will be slower than if you have, very high number of batches, but few iterations, it will be faster. So there is some kind of trade-off between which one should use. But I don't think there is any maybe something maximum number of batch one to use. I'm not sure anyway. Or anyone can attempt to answer also follow-up questions. Anyone can attempt. Let's ask. Yes.
I think if it's the size is going in multiple of 2, like you said, 8, 16, or 32, you can find his answer if you practice maybe with a higher number, maybe 64, 128. So
Okay, so yeah. Yeah, well, guys, guiding question then. This is what is the maximum batch size allowed? Oh, this is another. Oh no. Anyway, we can. Okay.
Because from this, can we have less than 8?
Yeah, we. I think it's even 2. We can have 2.
Okay.
Yes. So let us ask.
But the best thing to find this kind of answers is to practice.
Yes. So let me. Is there any maximum batch size in training deep learning model? So ChatGPT is saying there is no strict maximum batch size for training a deep learning model, but there are some factors to consider when choosing the batch size. Number one, the size of, okay, let me, oh, you cannot see, let me share with you guys. Okay. Right. Okay, can you see my screen?
Yep.
Can you see ChatGPT?
Yes.
So if you look at this one, you see like what this guy is saying. There is no strict maximum size for ChatGPT. I mean batch size for training model, right?
but there are some point, number 1, number 2, number 3. So let me just put this point for you so that you can be able to see them when I share. Let me put it in the collab. We don't need to go through them. We don't have time now. Let me put them in collab. Okay, so let me copy them and put them in the document. Does anyone use ChatGPT? This is my friend now. If I have any question, I ask him.
Yeah, so I use it every day.
We use it. We use it.
I just get,
Sometimes akwai lot of ina ga improvement. Akwai wasu abubuwa da na dan
yeah, I just get chat as research assistant. If I have any question, I don't need to ask almost by supervisor or I don't even need to go.
So amma ni abin da na samu wasu wata question ne mata irin wasu books ne na mata list na wasu journals da DOI din su sai ya zamto titles din daban DOI din daban. Haka list wajen guda 10 ne papers. Amma
Ai, ka san
sai
yi
kokari sosai. Sai a
Ita ba
hankali.
da akan internet take ba shi ne ba.
Ai na fahimta. Ai sai a hankali. Ka san tunda idan
What can
kana
you see now? Can
abin
you
da za su ringa improve.
Can you see my BS code? Can you see my BS code?
Haka akan net take.
Can you see my BS code?
Yes.
Okay, so you can see there is no strict maximum Y kaza, but there are some concessions. The size of the batch can affect the stability of the model during. A smaller batch size can make the model more stable, but can also make training slower. Yeah, a larger batch size can make the training faster, but can also make the model less stable. Can you see that? Because if you make the model, eh? Okay, let me. What about now? Can you see?
I can't see.
No.
Okay, but let me share again. I'm not sure what is happening. Okay, anyway, what about now? Can you see?
Yeah, we can see.
Okay.
The BS code?
Yes.
Yes.
Okay.
Yes, we can see.
Okay. So what I was saying is the ChatGPT. I'm not the one that gives, so don't expect I know this and I don't know. I just know that you will see we got it together. So, but I already explained the first one. That if you have small batch size, your model, the training will be stable. Meaning, when you say stable, it means it will be more accurate, but it will be slower because when you have 10,000 and you make the batch size to be like 5, 555, so the model can need to go 555, so it is slower. But when you make the model, you have 1,000 and you make the batch size 500, it will just update the weight twice. For the first batch 500, for the second batch 500 twice. But if you make it like 5, it will update many times so that it will optimize the weight. So you can see this is it. The amount of memory available on your device can also limit the factor when choosing the batch size. You can see larger batch size require more memory. So if you don't have enough memory, you may not be able to use smaller, but you may need to use smaller. In general, a batch size of 32, can you see that? A batch size of 32 to 512 is a good starting point, but the optimal batch size will depend on the specific model and data size you are working on. It may be necessary to experiment with different batch size. So you can see, Shamsuddin, you are saying experiment with different batch size. You can see your recommendation here. All right, so let's see the next one, which is basically the main things, training model in the batch size. So let's go on. So we remember what this TQDM, I already explained what it is, TQDM. Now we set manual seed. This is a timer, time the model start because I do not start training the model. So I set a timer, which I already defined before. How many epoch? 3 epoch. Now you can see here, I said for epoch in TQDM range in epoch, because in 3 epoch, I'm gonna use epoch, 3 epoch to train the model
or complete, how many rounds do I want to do? 3 rounds training the model to see the complete data set. But remember now we create epochs. So in each epoch, we need to remember this, I think. So you can see my data set now, I divided into epoch, right? So now I need to, for one epoch, so if I'm having one epoch, if I have 10 images, if I have 10 images and I want to do 3 epochs, now, and the images, 10 images, I divided them into two batches. So I have, for the first epoch, I need to update my weight how many times? How many times for the first epoch? Hello?
How many batch size?
I have 10 images and I
Okay.
have 2 batch size. How many times am I going to update my weight for the first epoch?
5
Yes.
times.
Yes, 5 times. So this means that here, this is what we are trying to do now in this code. So for the first epoch, you can see I have 4 epoch. You can see for the first epoch. But in each epoch, remember we have batches. So that is going through the second loop for the batches. So remember we have epoch, and that epoch is loop, doing loop. But inside each epoch, we have batches. So this is a batch for those epoch. Please, if you don't understand this, stop me so that we can make it more understandable. But because if you miss this, this is the wrong one. This is the, the most important things in training this loop. So you can see here for the epoch, I say enumerate. So what enumerate returns? You remember the first thing that enumerate return is the position. So when I show us enumerate here, when I run it, enumerate, the first thing it return, the first it return is the index. And the second one it return is the item. So you can see 0, 1, 2. So this means that here for batch, trend data, remember trend data loader return the X and Y. But when we call enumerate, then enumerate this, it means the first one, the first batch here, for the first batch here, it will be 0. The first batch here, it will be returned. And the X and Y will be assigned here. What I'm trying to tell us is that, okay, let me take this guy, enumerate here. You can see here, it returns some kind of stuff. So let me call a list here. Can you see it returns many numbers? So what I'm trying to say here is that I have large number of epochs. How many epochs do I have? Let's go back to how many batches do we have? Can somebody remember how many batches do we have? 1,000 something, right? Where is that thing? Oh, well. Yes, 1,000. Can we see? We have 1,875 batches of 32 each batch. So that enumerate, because I have 1,700, the first one, it will take the first one. So going through this code. Oh no, the time is going. Okay, so this enumerate, the first, it enumerate return 2 things, the position and the content. So the position, the first one will be batch 1. That is the first batch. Now we need to go through this. And now we can see our model. We instantiate the model. We said train model because we are in training phase. We know this. We make a forward pass. Remember forward pass. You call your model because we are model. And what is the X, the train data? We put it here. We calculate the loss. We already know the loss function. This is fn, we give it the period and the y, which is the target, right? Remember here, the model will give us logit, right? And this is logit, right? Because our loss function takes the logit here, white red. Can you see that? And now we calculate the loss. So remember here we initiate what is called training loss. So training loss we initiate to be 0. So here we update the training loss. So if we have a loss that is in this, remember we are in one epoch, but we are in a single epoch, the first epoch, but we are now in first batch. So we want to calculate the whole loss on one epoch. That is why we
Batch.
Yes, yeah, per batch, exactly.
Yes, per batch, yes.
Yes, per batch. It's a good one. So this is for a single batch. The single batch of data, but we want to calculate the whole loss on the whole batches. So here we can see we have this, and now we call our optimizer. We already know our optimizer. We will now call our loss back to calculate the gradient descent. And now we calculate the, oh no, this is the, what this loss back is, what do you call it? Back propagation, yeah, back propagation. Exactly. And this one we call SGD, so stochastic gradient descent, right? So we can see here we do everything. And now, because remember here, everything is in the second, inside a single epoch, one epoch. We do this. Now, remember, if we finish going through the whole batch in the first epoch, it will go outside of this. Now, in this first epoch, now we calculate the whole training, because this training loss, we calculate the whole loss we gathered here. Now we have training loss per epoch, because this training loss is not inside this loop. Can you see that? We have different loop. Do you understand what I mean by this? This training loss, do you understand what I mean? We divide.
Yes.
We divide the training loss. So that's one epoch. Now, still inside this, we have what we call test. Can we see that? So this test is still inside the first epoch. If we have one epoch, the first one, you can see we are still inside. So we calculate the test. So here also we test and test accuracy, test loss and test accuracy, we initiate them to 0, 0. And now here we enter into evaluation phase, and here is inference phase. Can you see that? Also put X in for test X in data loader. So, but here you remember, we here we can see we call enumerate. Here we are going into batches of data, but here because we are doing inference, it's not batches. We just call our test data. So for any point in test data, for any Y in test data, we have our test model, we have X test, we have the loss here, we can see that, we have accuracy, we calculate the accuracy, and now here we calculate the test loss. And now finally, we calculate the test accuracy division. And now also at the same time, we now print this one. So when we run this guy, this is what will happen. In the first epoch, remember first epoch is now doing this one. The first epoch, remember, we saw epoch 3. So the first epoch, the 0 epoch, is now doing this forward pass. So that's what it's doing. Can you see? Now it finished everything. It calculated the training loss, which is this. You can see the training loss. We put the training loss. The test loss, you can see we put the test loss. The test accuracy, we put the test accuracy. This is it. Can you see that? Now we have three epoch. So we can see this is the 3 epoch, and we can see the accuracy is 83%. The test loss is 0.4. You can see that. Now, when we increase the accuracy and the epoch to be like 20, and we run this guy, you can see it start going on. Can you see the TQDM is the one showing us this 0%? This what we showed us. TQDM here is the one showing us. So you can see in that. So this is how we train a model, PyTorch model in batches. So I will urge you to go and
so Doctor, this TDKM is showing the time taken for the epoch for each epoch or for the total epoch.
Oh, this TQDM. So we can see here for each epoch. So here for epoch in this range. So for each epoch, can you see that? For each epoch. So not batch, because all the batch, they are inside a particular epoch. So
yes.
yes. Because you can even see everything we calculate is for single epoch. You can see, so yes. Yeah. Okay, so you can see this is the batch. So I'll urge you to just go through this code and understand it. It's something that we all did previously. So now we want to make prediction, make a prediction as well. Okay, so just bear with me. We need to finish soon. So let's make prediction. So for us to make prediction, we define a function called eval model. So here we are not doing testing. Here because if you want to train our model, we need to have to test it. So we both have training section and testing section. That is how we can get accuracy, because you must have the training section and we must have what? A test section. So this is what this code does, train and test. But what about if you finish training your model and you want to make prediction on some data set, on unseen data set, right? You want to make train on unseen data set, right? You finish your prediction and you want to make prediction on unseen data set. So that's what we call this eval mode. So you need to pass the model you train. You need to pass the data loader. We already created the loss function, the accuracy, we all have this. So now here we can see we initiate the loss and accuracy to be 0, 0. And now we enter into model eval because we are doing evaluation, not training. And now we call inference. We are also doing inference. So here we also provide the X and Y from data loader and, make prediction, provide your X, and now you accumulate everything as well. The loss and accuracy, we can see them. You provide your prediction, prediction, and this Y, the true value, right? And now this is accuracy. We also provide the true value, which is Y, and prediction here. And finally, we calculate the, the loss and accuracy, and now return the model name, model loss, model accuracy. And now when we return the calculate this, so it will show us this model name, model loss, model accuracy. Okay. Oh yeah. Okay. So it's time to go to Freya. Now, yeah, it's already time. So I think we will stop here and continue next week. We'll continue. We'll come back to, we'll continue from here to just recap here and now build on. So what we learned today, we have seen how we can prepare a data set to do, train images. We saw how we can use data loader.